Hello everyone, and warm welcome to today's safety webinar with Accident. My name is Annie Emestein, and I work as a commercial product manager here at Accident. Together with my colleagues, I work towards creating the world's safest workplaces by always putting people first. This is done by creating innovative safety products to protect all of you in the business where you operate. The topic of today is protecting people with impact protection versus machine guarding. What can protect what, and what are the key differences between the two? Here with me today to talk about this topic, I have two of my colleagues, Matthias Schulz,
Hello, Annie.
machinery safety expert, and Marcel Derek Davis,
Hi, Annie.
the product manager of impact protection. But before deep diving into this session, I would like to encourage you to ask questions. So if you have any questions, please send an email to safety@excellent.com. So let's start. Matthias and Marcel, what is the purpose and function of machine guarding, and what is the purpose and function of industrial barriers?
Well, the main function of machine guarding is to keep people out of hazardous areas, obviously. Machinery moving fast, things that they could burn themselves on, hot parts, whatever. It could be something that turns very fast, could be a carriage moving back and forth. And a secondary function of guards is to keep the hazard contained, to keep it inside, like shavings flying out of the machinery, hazardous liquids being spilled, whatever. So these two functions, guarding and shielding.
Yeah, and at first glance, you could say industrial barriers have similar functions. The first one would be to separate or segregate pedestrians from vehicles, and the second one is asset protection, so to keep vehicles away from anything that needs protection. Really, you're trying to create safe areas where pedestrians can roam freely and hazardous areas where forklift trucks can operate.
And what are the key differences between the two?
Well, guards have to protect people, you could say, on a 100% basis, because usually they are about hazards that people can do nothing against. Just imagine a machine has just stopped, because that's part of the process, and now all of a sudden it starts running very fast. So the person would be totally surprised and in great danger when that happens. And also when it comes to shielding, people might not be aware of the hazard that is from the machine. So they have to really do that on a 100% basis. And that is also true because machinery usually is not set up to detect people that are inside during operation, because they're not meant to be there. So the person has to rely on the guarding to do the job all the time and 100%.
And what about the industrial barriers, Marcel?
So the main function is when they're protecting people or assets from manned vehicles. So that's the fundamental difference, is you've got human error. And then because of that, you need to have some of the responsibility has to land on those people. And you can never really truly make an industrial barrier 100% safe. And it's not possible. And that's in a big part because you've got large, heavy vehicles that are operated by people who make mistakes. So they can't offer 100% safety.
Does these differences also apply to situations where autonomous vehicles are used?
Well, in a way, yes and no at the same time, because you don't need guards to protect people from AGVs and AMRs, because they have sensors on board detecting the people, so they won't run them over. But then again, you have situations that are dangerous for people, like when an AMR approaches a docking station, the last bit, it has to switch off its sensors. Or when it approaches a transfer station where it is to pick something up, same thing applies. It has to switch off its sensory equipment. And you don't want people to stand in the way. And also, an AGV or arm might stop somewhere because of a failure. And that would be very bad, for instance, in a narrow aisle when there's a escape route there. So you might want to use barriers to keep people out of certain areas where these vehicles roam. So that's the role then of the barrier. We call them sometimes awareness barriers now. So make people aware of areas where they should not walk, where they should not go in, and then the AGV and AMR can operate safely and efficiently.
There's much talk about this the stability of fencing when it comes to impact of workpieces or even robots from inside. I guess this is not the case for industrial barriers, is it?
No, absolutely not, because when you think of how a barrier is constructed, they're typically vertical posts and horizontal rails, and you have gaps. You don't have continuous coverage, so there's a lot of potential for a workpiece or anything else ejected from a cell or a production line to go straight through the barrier. You can't guarantee safety.
Are there other marked differences between perimeter guards and barriers?
Yeah, well, parameter guards need to sometimes have movable parts, because during maintenance, for troubleshooting or setting, people want to go in. You don't normally have that on barriers. And they also need then, of course, a way to interlock with the machine function, so they will not allow the machine to start while a person is inside, or just after opening they have to stop. And when it comes to the shielding function, guarding is to protect people from relatively small particles maybe expelled, or also from liquids and other secondary hazards. And they have to be built strong enough to contain those. At the same time, you don't want really to use guarding to protect people from large parts that come flying at enormous speed. You would normally use them for anticipated hazards from the normal operation, like for instance shaving. That's an anticipated hazard. But a big piece like a workpiece or part of a broken tool, or even a machine that has lost control, or a robot that is running haywire hitting the fence, well, there's certainly a limit with that.
There are many instances where machinery needs perimeter guards, but also protection from impact by vehicles. So it appears that some kind of hybrid or fusion product would be desirable, serving both as a guard and a barrier at the same time. Do you think that is possible?
If you think about what a product like that has to do, it's got three functions. So it's got the guarding functionality Matthias has talked about. So you have to keep people out, you have to keep the daily operational emissions in, the small pieces of metal, that kind of thing, liquids. But then you have to have the impact protection function as well. And it feels to me if you were trying to combine all of those functions in something that really works, it's going to be either compromised or over-engineered. So it's not really viable today, I would say.
Yes, from the point of guarding, I would say the same, because usually industrial barriers have gaps that would allow, for instance, things that are expelled to pass through. So they would not serve the shielding function unless you really over-engineer the barrier as a shield.
And the biggest risk is, even if you were able to make a product like that can fulfill the guarding requirements, think what happens with a typical forklift impact. You've got a 3-ton forklift truck, say, operating 8 kilometers an hour. That hits that barrier. Is the guarding functionality really going to remain intact? And if it doesn't, your operations stop until it's safe to start again.
Okay, so what shall one conclude regarding the feasibility of a fusion product?
One important application for industrial barriers is to protect costly assets, and I think people should consider machine guarding a costly asset. If you consider what could happen if your guarding's damaged, it's always good to protect it. So I'd recommend isolating your industrial barriers from the machinery guarding, and if you're protecting your machinery guarding, by definition, you're going to provide protection to the machine inside that guarding.
And when you look at the main function of guarding, it is to keep people safely outside, also body parts like hands and the lower part of the arm that people might try to stick through. Usually on industrial barriers, you have more or less big gaps between two bars, for instance, that are put between poles. So the barrier would not really serve that purpose of keeping people outside completely. Unless they're over-engineered again.
Yeah, so we would definitely suggest separating the two products, separate industrial barriers with your guarding behind it.
So are there standards that apply to the design of machine guarding and industrial barriers?
Yes, there's plenty standards for guards and other safeguarding systems, and they have been around a long time in Europe, in ISO, and also American standards. And it's quite interesting that they are very specific concerning requirements. For instance, the 14120, which is the main standard from ISO for guards, it has a checklist of requirements that you can follow. So in designing your product, you can more or less tick off one point after the other from the list and make sure your product is up to specifications. And then in the annex to the standard, you have testing procedures that are meant to prove that you have met the requirements. So definitely we have standards for guards that are very clear, very specific, and can be used also to certify products.
And for industrial barriers, you could say we've got specifications in reverse. So you start with trying to design a barrier with a certain performance level, and then you work back of how to do it. There's no actual standardization of design specification. There's nothing that exists like that.
So in the absence of any standards, what responsibility has the consumer when installing industrial barriers?
Ultimately, even if there is no mandated reason to install barriers that are performance rated, you've got the health and safety executives in different jurisdictions. So in the UK, it's the HSE, in America, it's OSHA, and so on. And they have very broad and wide-ranging and strong mechanisms to enforce health and safety. So if you have unfortunately had an accident and you've been shown not to do something, they can use things like the Health and Safety at Work Act or the Occupational Safety Act from America to find you culpable, basically. So you have to ask yourself, have you assessed what's a very obvious risk? Forklift trucks or other vehicles operating around people or sensitive infrastructure are an obvious risk. Have you done something that's in best practice? Have you done something that's reasonably practicable? And if you haven't, you probably should.
As there is no standard available, what can I do to choose and place safe industrial barriers?
So as we've talked about, because there are no black and white, no really concise standards to follow, the best thing to do is have a really pragmatic approach to it. So you can start to look at the basic level, what risk reduction will these measures reduce? And for some applications, there are some standards from other sources. So you take pallet racking protection, for example. There's FEM guidelines that are referenced in the EN standard for pallet racking. That's specifically for pallet racking protection, but we can use the approach that teaches us for other types of industrial barrier protection. And that's a very good place to start, I'd say. And regardless of how you derive what barriers to use, it's quite obvious that anything is better than nothing. You're reducing the risk by putting some barriers in.
You highlighted that risks from applications are key in deciding what to choose. So would you recommend a risk assessment in order to support your decision making?
Definitely. As in machinery safety, the same would apply to choosing impact protection. Risk assessment should be the first step to take, because you want to start from knowing what to protect, what type of machinery, what type of infrastructures you want to protect, and also from what you want to protect them. What is the type and size of vehicle? What is the speeds? What is the weight? What is the space that's available? These all help decide what type of barrier to choose and what performance rating you want on them. And also I think that when you talk about barriers, you need to analyze carefully traffic on site, and that you should do aided by a site layout, and then watching actually traffic or planning for future traffic. Where is people, where's manned vehicles, where's unmanned vehicles, and how do they mingle? And then you can come to the right decisions on what sort of barrier to choose and where to place it exactly.
So are you trying to say that the type of 100% safety level could be reached with barriers as is required with guarding by machinery?
It's definitely not possible, because you consider the environments they're used in. by the nature you need them, you're going to have pedestrians and vehicles mingling together. So to ensure some kind of 100% safety, you would be putting in so many barriers, so many safety measures that you would really reduce the operational efficiency to the point it's not viable. So it's always going to be a compromise.
Yeah, and I think this would apply likely even more to production areas than maybe warehousing areas, because in production areas you will have people present more or less all the time to fix certain problems, to do minimum setting, troubleshooting, and so on. So at the same time, you will have trucks coming in to bring raw materials and fetch finished goods. So it's not really possible to make a type of 100% separation between people and truck traffic. So people will have to pay attention to a certain extent to what's going on around them. Barriers can do their work. No? They can certainly play an important role, but they cannot guarantee 100% safety like guarding will have to.
Okay, so when it comes to barriers, we can only talk about the degree of risk reduction. Is that correct?
Yes, you can use the hierarchy of risk reduction to reduce the risk. And if you talk about designing away risk, I think we have to leave that to the vehicle manufacturers, and there are technologies coming that do that. And then what we can do and what you can do is the operational, the physical measures, i.e. barriers. And then finally, you can look at training and information for use. And by doing that, you can find a balance. And you can use these codes of practice that are in existence, and you can certainly use the EN standards for risk assessment. But I'd urge people to tread carefully because there's lots of conflicting information. I talked earlier about the pallet racking guidance, for example. So the FEM guidelines, which are referenced by the EN standard, are then contradicted in Germany, as an example, by the DGUB, which is a regional standard. So there's lots of examples like that. So you have to take a really pragmatic approach, use all these tools that are in existence, and take considered risk assessment and reassess your stacks.
Yes. And finally, a final consideration is also that you don't talk about safety here only, but you also talk about operations being smooth. Like when more and more AGVs and AMRs come in, people will disturb them, obviously, by walking certain areas. And you will want to use barriers to raise the awareness of people that these things are there and to keep them apart. Not only for safety, because safety is on board the vehicles, as Marcel just said, but to ensure efficiency, because an AMR can't run efficiently if it's constantly having to stop because of people roaming its paths. So that you also want to plan into your considerations to keep people out of docking areas, keep them out of transfer stations, ensure that they are not trapped somewhere in a narrow aisle in an emergency situation. All of that needs to be considered also when planning for use of barriers.
That was all we had for today. Thank you, Matthias and Marcel, for an interesting discussion. And thanks to all of you who have watched this webinar. And as I mentioned in the beginning, if you have any questions, please send an email to safety@axcellent.com.